Well, guys, I made a new friend down in North Carolina, and I was very happy to see that this came in yesterday through priority mail, this box here. I'm not going to say his name because he's a private person. He might not want his name splashed about in my videos, but I just want to give a shout out in case he sees this. John, I got your package, and I really appreciate you taking the time to save this little piece for me. John worked at a place down in North Carolina where they had a Hendey, I think it was a 16-inch tie bar or a 14-inch tie bar Hendey lathe that they were scrapping. And when I initially got into a dialogue with him through the internet, we talked about the possibility of him getting me several parts I might be able to use for my lathe. I talked about the tapering jig issues and all that I had. And I think there might have been some other things with that lathe. But what ended up happening, unfortunately, was he was only able to remove a couple of pieces before the employers that he worked with scrapped the lathe. They initially had given him the impression that they weren't in a big hurry to get rid of it, but then I guess for whatever reason the opportunity to get rid of it presented itself, and they before he knew it, in the blink of an eye, it was gone. So another Hendey has gone to the maker in the sky. But he did grab off the U-shaped piece for the tapering jig, but he took measurements for me, and the bolt spacing indicated that it was going to be too big and would not fit on my lathe. So that basically confirms what I've already come to learn, which is that the 16-inch version of this lathe has a much bigger carriage, so it has a bigger tapering jig on it, so those pieces aren't going to work. The one other piece he was able to save before it went to the scrapyard, because I had mentioned it, and seeing the photos he had sent me, was threading dial. I saw the threading dial and I said, boy, if you can grab the threading dial, I'm not sure if it will work or not, because, again, 16-inch lathe. So that's what he was able to send me at, basically for the cost of shipping, he sent me this. So I am very grateful to him for going through the trouble of saving this artifact off of that Hendey. I've talked about in the past that, these Hendeys supposedly don't need threading dials to do threading, and, we'll cover that at some point, hopefully in the future. But that my understanding is that it is an accessory that many of the Hendeys did have, or you could order for the Hendey, and so it's not a horrible thing to have. That being said, I unpacked it and I just checked it, and there's good news and the bad news. The good news is the lead screw seems to mesh perfectly. It looks like the thread pitch is exactly what it should be. Let me turn this light around. So here you can see my my old friend who was the owner of this lathe before me. You can see his little homemade jig here. He's got this little bent piece of metal with this little gear, and he's just got a little bit of paint on one spot there, and it's a crude threading dial. So here's the nice Hendey dial with the cast housing. It's a little stiff, so I'll probably try and take it apart and clean it up maybe. But the point that I wanted to make was that you can see how stiff it is. There we go. You can see that you just watch the teeth when I do this. Well, anyways, point is that it does. It seems to be the right pitch of teeth on these. I'm not saying that right. Meshes nicely with this lead screw, which is good. I was worried that if the 16-inch lathe had a larger lead screw and it might have had a different pitch diameter or something like that. But that's going to work out. But there are no mounting holes evident anywhere on the side of the carriage here. The apron might have had something there. I've got this little hole that he's got this screwed into, but I think he may have drilled and tapped that hole himself. Behind here there might be a larger hole, but that's all academic, because even if I mounted, you can see this was supposed to be right here, supposed to swivel on this bolt, and oops, if this was mounted here, you could see that would be way too low. So what's going to happen for this threading dial to work on this lathe, I could actually rest it right on top of the homemade bracket, and that's pretty much where it's got to be height-wise. So you'll see that puts this whole part way up high. So here's what I'm thinking. Hold on a second. So here's what I'm thinking. Mount it like this. Okay, right? Fabricate a block that would bolt down. I'll have to, drill a couple holes and tap them. Bolt down a block here, and in the side of that block have a drilled and threaded hole that this bolt would thread into, and just let this thing kind of ride like this, And then it's got this pin. It's actually got a couple of things going on here. It's got this pin right here. I'm not sure what that pin, the deal on that pin would be. But if I do this right, the pin would act to basically keep this from being able to swing out too far. Not that it's going to. So, I don't know. But, we got a long ways to go before we're ready to worry about adding on accessories like a threading dial. Hey, wouldn't we want to see this thing actually just up and running and doing something simple like turning something or facing a part? But point is, at least we were able to save that. It's a nice little artifact from a Hendey that has gone on to meet its maker. This bolt was in here. I'm not sure. I think that was just accidental that he put that in there. So, anyways, just wanted to show you guys that. And I'm in communication with another individual who's also got a Hendey that's being scrapped, and I believe it's also a 14 or 16 inch. And he had they actually had some other stuff too, an extra chuck, but not a Hendey chuck. But it was a small enough chuck that we were looking at it, and he and I both agreed it'd be a nice thing to have, that I could chuck that chuck in my big 4-jaw chuck, and then I'd have basically a 3-jaw that I could use for smaller parts. So we've got a preliminary deal working there, which hopefully if we can finally iron things out, I'll be able to get that. The thing that's holding it up right now is he's got that item, and then when he showed me a picture of that lathe, I noticed there was a carriage stop. This is a micrometer stop, and then there's a straight carriage stop that was also available for this. He's got that on his lathe. I'm not sure if this these diameters are going to be correct here and if it'll clamp on, but again, it's cheap enough, I'm willing to take a chance. So I asked him for that. Not quite sure what I would actually need it for now that I think of it, because I can't think of why you would need multiple stops. Yeah, anyways. He's got a face plate or dog plate, and we can't figure out what it fits. His 16-inch tie bar lathe that they actually have another one in the shop that they use, and so they were taking a lot of parts off of this lathe to fix that one. But he said that the dog plate didn't fit either one, but he gave me the dimensions, I think, of what his 16-inch Hendey uses for a spindle, and it's larger. So what I've got to figure out is I want to figure out what this is. It's got a taper to it. So that's tonight's little mission, is going to be to try and get an accurate measurement here on this. Oh, just a quick comment. I haven't finished the chip pan, prepping the chip pan yet for primer. I just, I'm having a little trouble getting excited about doing that job. It's nasty. Alright, so basically there are two numbers that I want. I want the diameter of this, not the nominal diameter, I believe is what they call it, or the pitch diameter. I'm not getting my terminology straight, I don't think. But anyways, I want to get that measurement, and I want to get the threads per inch. I'm going to do the threads per inch. I already actually did it. That's the easiest thing to figure out, especially on something as big as this. Basically, threads per inch is exactly what it implies. How many threads per inch? Now, there's a couple of ways we can determine that. On smaller threads, like nuts and bolts like that, it's a little harder to do. All right, what I meant to say is that it's not harder on smaller threads. It's harder on smaller threads to count the threads by just holding a scale up. On smaller threads, you could use something like this. This is a thread gauge set. This one is rusty because I found it in a toolbox that had gotten wet. But the problem is that this is the largest thread size that's in this gauge right here, and this is a 10. So this is 10 TPI, or 10 threads per inch, and you can see that's not going to work. So we can pretty much move on to the next method. Oh, it's funny, I just went to look for a small scale, and I've got a old green toolbox that I bought at auction quite a few years ago, and it's loaded with machinist little odds and ends, and a lot of the things I had no idea what they even were when I bought the thing. But what I found was I found another thread taper gauge, and this one's got big ones. So now, so basically to use the thread gauge, it's pretty simple. You basically, you would find one that's close, and you fit it. Obviously that's too big. You find one that fits in there perfectly. Okay, that one. What is that, out of curiosity? Oh my, hold on a second. Alright, this is a good one. This is a Starrett. That was 7 that I had just tried. And this is 8. And that, I don't know how good that's going to come out on the video, but hoping you can see that's a perfect match. So that's how I know that this is going to be 8 TPI, or 8 threads per inch. Now, if I didn't have this handy little gauge, again, because these are so big, what I could do is I could take a scale and hold the scale up, and I could literally just go right down and count how many, if I put the edge of the scale on the first top of the first ridge, and then count 1, 2, 3, 4, 5, 6, 7, 8. You'll see that the 8th ridge lines up right with the 1-inch mark on my scale. So that's the other way to do it. And then of course the other thing you could do is you could just take a caliper and set the caliper to 1 inch and put your point right in one groove, and then count how many grooves before the next point is in. 1, 2, 3, 4, 5, 6, 7, and 8. You'll see that it's right in the groove there. So that's easy peasy Japanesey right there. 8 threads per inch. Alright, so my plan was to use what's called the 3-wire method to measure this. Find this diameter, this magic number that I'm looking for. The problem with that is the 3-wire method, you basically use 3 little wires. And if you had a set, which I don't, basically it would have all these different wire gauge sizes in it. And there'd be triplets, little, 3 of one size, 3 of the next size, 3 of the next. What you do is you put 2 of the wires in 2 grooves right next to each other on the top, and then you would put the 3rd wire actually opposite to where those 2 wires are, and then you take a micrometer and you take a measurement right there. And there's a whole calculation involved in that, and I'll get into that hopefully. My problem is I don't have the wire set. Now, I don't want to buy a wire set because I don't know when I'm going to need it again. So what I was thinking of doing was I was thinking of maybe starting the process seeing what size wire I need and seeing whether or not I can find something that I could use. Like maybe I might be able to find 3 finish nails, depending on what size those are. I do have a nice original Starrett wire gauge. So if I'm able to determine which size wires I need, maybe I can use my gauge and find something here in my shop that will work. I've got this pretty sorry looking micrometer that I pulled out of that same wet toolbox, that toolbox that had gotten wet. And let's see if I can see a maker on this one. This is a Reed Small Tool Works of Worcester, Massachusetts. Reed Small Tool Works of Worcester, Massachusetts micrometer. Isn't that something? So my thinking is, why don't I take a measurement with this for starters? And yeah, I mean that anvil is not looking too great. Well, so the other thing I'm going to mention at this point is that guess what else we've got going on here, which is that this is a tapered thread. So my measurement here is going to be different than my measurement here. So what happens is when you're threading this chuck on, it's actually loose when you first thread it on, which is supposed to help aid in basically making the chuck up, mating it up. And it tightens up when it gets up here. So if I take this spacer off and look, I can see the threads go all the way up to here. So I'm thinking I probably don't want to be concerned with this minor diameter here. I'm thinking I'm either supposed to probably take the major diameter or maybe halfway between. I'm not positive, but I'm going to go with the major diameter. I'm going to take the diameter that's up near the top here. And let's see. Am I going to even be able to... I think I need a bigger micrometer. I've got my calipers. I could just do with the calipers. I kind of wanted to play with the mic though. Alright, that ain't happening. Okay, so I did a little looking around here, and turns out I do have an old acquisition, a Brown & Sharp 1 to 2 inch mic. So that's what I'm going to use here. And okay, so that's my minor diameter there. But again, I don't want that. I want up here. So let's see if we can't get on there. And I kind of want to feel around in there, and so I think that's it right there. So ideally I would lock this mic, but I can't do that on this model. See if I can't get this off without disturbing the setting too much. Now we're gonna play Watch the Newbie Try and Read the Micrometer. Alright, so what I was able to figure out is that I figured out I'm right near 975 thousandths. Each full revolution of the barrel here is 25 thousandths. So that's 975 thousandths there. If I go around one more, that's exactly 1 inch. This is actually a 1 to 2 inch micrometer, so I add 1 inch to it. So it's actually 2 inches right there. But getting back to here, this was 1.975 inches, and I was actually at 22, so that means I'm 3 thousandths below that. So my measurement's going to be 1.972. Now, just for giggles, I'm going to use my dial caliper here and take a measurement. I'll read this upside down. So let's see, that's roughly 1.9, I don't know if you can see it, but it's just above the 70. So it looks pretty good. So I'm going to go with 1.972.